So hello everyone. So today we have the mock interview, mock PD mock interview with our experienced candidate. So hi, can you give the introduction, please?
Yes. So my name is Ashwati. I have been working with Intel for last 8 years. So I started my career in 2017 as a physical design engineer. There I worked on partitions. I worked on projects like Jasper Lake and Meteor Lake. I worked on memory controlled partitions. Basically, I worked on synthesis and the complete flow, PNR flow from floor planning to till routing and sign off. And later, I moved to analog circuit design team. There, I worked on some of the partitions of low jitter PLL. Basically, evaluated the performance and at different PVT conditions, and I also worked on a level shifter to reduce. I worked on, to reduce the duty cycle distinction of the level shifter. Later, like after
Okay,
2 years,
okay.
I
So
moved
when
to.
did you recently step out any project like
Yeah, like after
hello?
2 years, I moved to a PDN team where I was responsible for developing test cases as a part of IRRV flow development. So in that team, I developed implemented test cases. I also implemented the meme cap on the reference power grid and the meme cap to see how the IR drop and PDN impedances improved. So that's what I did in the
Tell me about the last projects you have done. Tell me about the last project you have done. Which was your last project, and what is the end-to-end PD flow for that projects, and where you work exactly? So where was your work in the last projects in the PD flow, end-to-end PD flow?
that was like 4 years, 4 or 5 years back. Like that was a Jasper Lake project for Intel 7 nanometer. Um, and then worked on a Meteor Lake project in 5 nanometer. There I worked on BDM partition. In the Jasper Lake, I worked on a memory controller subsystem. In that, I worked on a microcontroller scheduler partition.
Okay, okay. So what were the challenges you have faced there?
So challenges, meeting the timing was one of the challenges for this MC scheduler partition because this partition was like a heart of this memory controller subsystem because it's mainly um, um, it handled the request arbitration and sequences from it basically collects the request from multiple sources and passes through the downstream logic. So if any delay in this scheduler partition happens, it will impact the whole system. So that's what the meeting the timing was the biggest challenge for this.
Okay, okay. So you have worked on a SOC blocks also, right? So like how you decide like whether I have to go for hierarchical or flat PD for large SOCs? Whether I want to go for flat PD or hierarchical PD for the SOC block. You have the idea about this?
Hierarchical means if the design is too complex,
Okay.
then design is too complex to handle, then rather than going for a flat design we can go for hierarchical. So each subsystem can be handled by multiple people, and we can meet the PPA for each block before the deadline.
So large, I am already saying that is a complex design. So like how you decided? Going for the next question. So, what are the key checks you before starting the CTS? What are the different key checks before starting the CTS?
Before starting CTS, I check for the congestion and utilization. Congestion is in control and utilization looks okay. And the I check for the setup time. Setup timing is in the allowed limit, and also the DRVs like max cap and max trends are in control. That's what we'll check before CTS.
Okay, okay, okay. So how do you debug the post-routing timing violations? So what are the different methods that you can debug the post-route timing violations that cannot improve the sizing?
Post routing timing violations.
Yeah, how you can debug this post-route timing violations?
Um,
Okay. Hmm.
like check for that particular path, and if we can add buffer on route, or we can size the cell. Um, uh, yeah.
Okay, okay. So, what is the strongest area in the PD you have? Which is your strongest area in the PD?
Which I have worked on is um, mostly timing critical partition. So in order to fix those, I always have to do the some alterations in placement and CTS all the time. So I think placement CTS all the way to routing, and the iteration happens to fix the timing. So that's what I mostly worked on, and that's where I faced most of the challenges. So I think
Okay.
that is the strongest.
Okay. How do you approach the floor planning with multiple voltage domains? What is
With
the approach you have for the multiple domain voltage domains?
with the multiple voltage domain, we'll check the which macros belongs to which power domain, which accordingly we'll create different power domains, in the sense like different create different voltage areas, and um, you know voltage areas, create different voltage areas at the same time, like in the floor plan itself we'll add the um encapsulates around all the voltage areas. Then mm,
Okay, fine. So,
um, I think this will it can I add
mm,
like power planning also in this, like
yeah, you can add. You can add.
we can create the power rings and mesh for this um, according to the voltage domains, different power domains.
Okay, 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 okay. So, what is the difference between static IR and dynamic IR and transist IR? Do you have the idea about the static dynamic IR?
Yeah,
Why you
static
do?
IR is basically uses the average current, and dynamic IR uses the switching current, where when the logic switches or SRAM or PLL clock switches, it uses the transient behavior of the current. So static IR basically check how robust your power grid is. Uh, in the early stages of power planning, we can that uses the steady state current. So in that case, we can check the robustness of power grid. If anything is broken or VI is missing, that kind of thing we can do with the help of static IR. It actually takes less run time, and so the static IR is preferred. But uh, in dynamic IR, it has the current has a transient behavior, so it not only has the resistance, it also has the capacitance and inductive behavior. When you say the drop V equal to IR, the static IR drop, it will have only R effect V equal to IR, but in the dynamic it will be V IR plus that CVdV by dt effect will also be there, LDI by dt effect will also be there.
Okay, okay, fine. So, what factor decide macro placement in a consisted block? What are the different factors that decide macro placement in a consisted block?
Uh, Congested. You mean what all factors we need to consider while placing those macros?
Yeah.
So we need to check. We can use the fly line analysis first, like to find the connectivity. So which macro is talking to each other, or macros talking to the port. Accordingly, we can place macros. So if macro is talking to a particular type of port, we can place closer to that port, and macros of the same hierarchy we can place together, and you know, it's always good to place the macros around the boundary because it leaves space for the logic to place in the middle, the center of the partition. Otherwise, it may create a lot of congestion and routing issue if you place at the middle. And always make sure that we add halos around the macros, because this is a high pin density blocks, right? So it always, it always create routing. So we need to add halos around the macros. Also, make sure that sufficient channel spacing is given between the macros. If macros are talking to each other and it's not, there is, we can abort in case if there is no like pin issue. If it is different, then it should be non-aborted, and we need to leave sufficient space between macros.
Okay, fine. Okay. So what is the most common DRC issues you have faced in the advanced nodes? So you have faced some DRC issues in any of your projects?
Yes. So on advanced nodes, mostly like 89 nodes and all, it's what I saw is mean spacing issue, because it's very congested and the tracks are very limited, right? So mean space issue I usually encountered, and also the global density, local density violations, DRC violations I have faced.
Okay. So what are the necessary checks before final CDS handoff?
CTS.
Or CTS handoff before giving the final CTS, what are the necessary checks?
So we'll check for the skew latency target, what we have specified in our spec file. We'll check for that whether we met or not, and the hold timing, whether it met in the it's acceptable within the limit, and also the DRVs like max clock transition, fan out, and um, max trans, max fan out violations. We'll check whether it met the specified target or not.
Okay. Okay. So you know about ECO? You know about the ECO techniques?
Yeah, engineering change order. That is the last minute change we do
Mhm.
after routing, because we expect minimal change, because the base layers are already fixed, we don't want to disturb it. So we need a minimum changes, like if timing issues we change, maybe um we add buffer on route, that kind of minimal change we do, and rerun the timing again.
Okay. Share an example where issue fixed timing but caused new sign of issues. You have some issue, like you have faced some example that you have fixed the ECO, but it have created the new sign of issues. So you can give me some of the
Like
example.
fixing timing sometimes causes um, um, IR drop issue, because the resistance may change, and the voltage drop occurs. So fixing
I'm asking
timing,
for your projects. Do you have with your experience? I'm asking. You have faced some issue like this?
I think I have, but now I'm not able to recollect it. But
Okay,
yes,
okay.
maybe I have to.
Okay. Mm. So, which is your strongest projects from your like resume currently? So, and why you are shifting for analog and PD? Like both are different, right? So, tell me the difference between analog layout and physical design. So, what is the difference?
When I was doing the physical design, right, I always when I was working on some blog, I always wonder like how this macro, some PLL and all. When I see this, I really wanted to at that time I wanted to explore what is happening inside this, and also I got to work with an analog team for this one of the projects. So I started liking that analog team. So I I slowly uh, taken one of small the partition and started doing simulation. I really started I started liking that, so I thought I will switch that domain. That's what I moved to analog team. But what happened is there was some intel no that there's reorg happens now when the so that is some due to some reorg change. I couldn't remain in that team. I had to move to a team where it was PDN, where again I started my PD work. Though it is a PDN team, I was doing a physical design work for that team.
Okay, fine, fine. So, tell me the difference between local and global routing.
What is that?
Local and global routing.
Okay. So, um, so in the routing, if initially uh, it will just divide the entire design into different G cells, and it's approximate. Okay, the uh, it approximate the routing distance. Okay, from this cell to this, that is called the global routing. And once the routing track is assigned, it's actually the metal physical connection will be laid off. That is called the detailed routing.
Okay, okay, okay. So, how you decide the PNR for the high frequency CPUs versus low power SoCs? So, how you decide the PNR? Sorry, PDN for
Uh,
the high frequency CPU versus low power SoCs.
um,
So, what are the major factors? So, how you decide?
for the low power, you mean for the low power design?
Yeah, low power SoCs, low power design. Yeah.
Um, Low power design, I go for this multi power domain technique.
Mhm. Okay. What are the techniques? You can tell me the name. You can explain it a little bit.
Okay, so we can go for this multivity cell. So if it's a non-critical timing path, we can always choose HVT cell. So HVT cell is less leaky in that. So non-critical path we can use HVT, and critical timing paths we can use LVT because LVT is less delay. It's care for a timing to meet. Um, and we can use multi voltage domain because in the entire associate does not require the same voltage, right? So whoever need the timing fast, like to a high performance portion will be there. For that, we need higher voltage. So apart from those part, we can assign different voltage. In that way, we can reduce the power, because power is directly proportional to the voltage, the dynamic power. And one more thing, we can use the clock gating cell. We can stop the propagation of clock to a particular logic when it is not in use or an ideal case. So we can use clock gating techniques like ICT cells. Um, Also, the power gating techniques, power gating switch we can use similarly to stop the power.
Okay. So, how you ensure the noise isolation for the sensitive analog blocks since you have worked for the analog, right? So, how you ensure the noise isolation?
Noise isolation for that. Uh, for the particular region, we usually use um, shielding or different routing techniques like double width and double spacing, basically to reduce the coupling capacitance between two nets, so that the crosstalk noise will be reduced. Also, in the high switching region, we can add the decap cells or min cap cells.
Okay. Okay. So, you know about LVS and DRC? So, what is the difference between LVS and DRC rule checks?
Difference between LVS and DRC.
Yeah.
DRC is basically a set of rules given by the foundry, like uh, this has to met, like maybe minimum metal has to obey this rule, like minimum width, minimum spacing, minimum area via enclosure. Those set of rules have to meet in order to manufacture or fabricate the layout, right? LVS is a layout versus schematic. Basically, it's checking the layout
Hello.
matches the scheme. Can you hear me?
Yeah. Yeah. Yeah.
Can you hear me?
Yeah. I can hear you.
Yeah, DRC is basically like checking whether we are meeting the rules defined by the foundry, right, in order to manufacture the layout properly. Otherwise, manufacturing will be difficult. The rules like min width, min spacing, min area, the via enclosure rules, density rules, those kind of rules. But LVS is just a layout versus schematic check with the final layout, the GDS versus the netlist check. It matches or not. That is the difference.
Okay. Okay. So, what is the biggest PD challenge you have faced in like of your projects? Like on all the projects, you can tell me projects by projects and the tech challenges for every project you have done.
Um,
You can tell me like you can refer your resume and tell me projects by projects. You can tell me the challenges and how you resolved it.
okay. So for the Jasper Lake project, I worked on the memory control scheduler partition. So it actually receives multiple requests from different sources and passes through the downstream logic. It's basically it has a lot of data. I mean logic depth. It has a lot of logic depth inside this. So meeting timing was the challenge. So it always violating the timing. So the basically I fixed this by logic restructuring and sometimes adding buffers. Those kind of techniques I have used for the in the early before sign off in the PNR tool itself. That is the approach.
Next project, like I am asking projects by projects.
Okay, next project. Next project, it was for the Meteor Lake project, it was a ODI VDM partition. VDM partition was it's a voltage Drop manager. It's actually uh, um, it's like a interface between all the blocks, because the high switching blocks is actually a droop sensor. Whenever a droop occurs, it will sense and detect, and ODI it will sense and detect, and accordingly it will um, change the voltage by sending some signal. So it has a lot of control signals and interfaces, lot of pins. So pin density issue was there. Also, it was talking to multiple uh, high switching blocks of different voltages. So it was multi voltage domain and high pin density blocks. So um, uh, congestion was one of the issues, and so we had some uh, I think some micro rearrangement, or it was around 10 or 5, less number of macros only were there, but some kind of rearrangement has done to fix this density issues. And uh, other issue was multi voltage domain, this level shifter, and all the isolation cell always add some extra delay for to the timing path. That was little challenge, because we can't really move or do anything to this level shifter isolation cells. That was the challenge. Then we had to concentrate on the other logic path and restructuring. That's how I fix those parts.
Okay. So what are the technology nodes you have worked on?
I have worked on 7 nanometer, 5 nanometer, and in analog 3 nanometer. And finally, in the PDN team, I worked on 18A. That was back power metal, power delivery on the back side of the wafer.
Okay. Okay. So you have integrated the analog IPs into your like PD SoCs also, like PD design. Have you faced any problem in integrated analog IPs into the SoC PD flow? Have you done the
No,
integration of both?
uh, I don't think analog BDM. Also, it has like small hard macros uh, for the droop sensing and detection. I don't think there was no
Okay. Okay. Fine. Fine. So you have worked on ST also?
STA.
Yeah.
Yes, but for us, there was separate STA team for the sign off, timing sign off.
Mhm, mhm. Okay. Okay. So there was some team under you also, like of the juniors you had. You have some your
Mm,
juniors also in your projects.
mm,
So how you
no,
no juniors were there in your team, like
for
under you. For
when I
the
was doing these two when I was doing these two projects, I just joined Intel, so I was the most junior person at that time, like 5 years
okay,
back.
okay, okay. And when was your last like PD or analog projects? Like what was the last working day in the company?
Last pure PD was like 2020, I think, from 2017 to 20.
20. So after 20, what are you doing?
Analog for 2 years, then again to a PDN team that was kind of PD plus IRRV PDN, or all this, the mix of this.
So that is also PD, na? That is also PD.
That is also a kind. Yes, yes. I
So
thought pure PD, like from synthesis to the sign off. So it's the latest team. It's it's more of implementing the min cap on the block. That was the main task. Like we need to check how in the 18A node how this meme cap behaves, and especially the power is on the back side. So that's what we try to implement.
Okay, okay, okay. You know what EM limits also? Like what are the, how do you ensure the ECO doesn't break the IR drop or EM limits? How you ensure the ECO doesn't break the IR drop or the
So once we do the ECO, so we need to check timing and IR drop parallelly, relatively.
Okay, fine, fine. So I will suggest you just go through the revision of the basics and everything, right? So
Hmm.
that is important right now for you, and just work on the projects also nicely, right? So that is important for you. Like you can just prepare it
Okay.
within 10 days, 5 days, whatever you need. But just prepare the basics and everything nicely and work on the projects also. Let's say I'm asking the projects like major challenges you have faced. You have to tell that this is my first project. I have faced this problem, state problem, and I resolve this problem through this thing, right? So projects by projects, first name, second name, third name, that will be more like interesting also for the interview, right? So rest of the things you have to clear the basics and everything, right? So just work on the skills first, then we will go for the next round also, fine. So any questions you have?
Um, no, I want to ask something like maybe it's recording, right? So I just want to,
Okay,
let me
okay,
call.
just